Hey students, this is Mrs. Tran-Bloom. I am recording on 2.7, writing polynomial functions. So the first thing we're going to write down is the definition of a polynomial. And I believe Mrs. Lassner touched up on this before. So a polynomial function has only positive exponents, okay? It is in the form of f of x equals a subscript n. Don't be scared of that. That's just saying it's the a subscript n, it's just the coefficient, times x to the nth power. And we can have as many terms as we want. So plus a subscript n minus 1 times x to the n minus 1. And we can keep on going. So dot, 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 plus, I'm going to write two more terms at the end, a subscript 1 times x to the, technically students, this could be a 1 power, but we normally don't write a power of 1. And then the last one is going to be a constant, so a subscript 0, and we don't have an x because it is a constant. Okay, so let me give you some IE, so in examples of what a polynomial would look like. So IE, f of x could be like this. So this is one of the many, okay? 5x to the 9th power plus 11x to the 8th power minus 4x to the 2nd power plus, let's say 3x, and let's make a constant of 100. So that could be a polynomial, meaning that we have more than one terms. In this case, we have one term, two terms, 3, 4, and 5. There are 5 terms here with a constant being 100. Now, factor form is when it's written out all as each factor. So let's just, I'm going to give you something like this. F of x equals, we can have a leading coefficient in the front, let's call it a, and then the factor is going to be x minus, let's say we have factor number 1, so it's going to be the root 1, okay, times x minus root 2. So 2 roots would make a quadratic, and then dot, 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 3 roots would make a cubic, and we can have unlimited number of roots. So the number of roots will tell us the degree of your polynomial, okay? Now we are going to talk about standard form. So standard form is like the definition of a polynomial. So something like this, guys, that would be in standard form. So standard form of a quadratic. So I'm going to write a quadratic standard form. Okay, it's what we've seen before. F of x equals ax squared plus bx plus c. We can even do a cubic standard form, okay? So that could be f of x equals ax cubed plus bx squared plus cx plus d, right? Now these last one, as you can see, there are no variable x multiplied to it, so those are called a constant. So a cubic, it just means the degree of the function is 3. Given the solutions or roots or zeros or x-intercept, those are all the same thing. We can go backwards to create the original equation in factor form, or again, guys, factor form, we can also use the word intercept form for it. The reason we call factor form intercept form is because it's easy to find the x-intercept, okay? Let's read the boxes here. The number in the box I meant. Number 1 says each root okay? The root is r. Can be written as a corresponding factor. So that means we're going to go back and we put it back in as an x minus that particular root. Write the equation in intercept form. Intercept form is the same thing as called factor form, which is all of the factors being multiplied together. So the quantity of x minus root 1 times the quantity of x minus root 2 times the quantity of x minus root 3. If you have 3 roots, then that would be a cubic, right? If you have 2 roots, that would be a quadratic, based on the number of roots. Number 3, remove fractions by multiplying a certain number, a specific factor, by the denominator. Irrational, okay, and complex factors always come in pairs, and that means they're conjugate pairs. And multiply those first to make your values prettier, okay? Let's try a couple of these. The instructions for examples 1 to 6 states, write a polynomial function with your x-intercepts given. We will use the leading coefficient. A is 1 for these examples. We will change it up and make it a little bit more difficult in Unit 3. Then we are going to use decimals to graph and sketch the graph on those ones, okay? So as you can see here, number 1, you are given 2 roots, okay? 2 x-intercepts, 3, 0 and negative 4, 0. Because you have 2 roots, this will give us a degree of 2 because there are only 2 roots. That means we are looking for a quadratic equation, okay? And a quadratic equation is going to look something like this. Y equals a times x squared plus bx plus c. So that's what we want to look for. So we have root number 1, root number 2. We will start with, since normally we do have an a times these roots, okay? But our a is currently stated right in the instruction. We are going to use only 1. Oops, I meant to highlight that. Only 1 for these sets of examples. So all of the a's will be 1s for these examples. So y equals 1 times. Again, we have 2 roots. So each root will be x minus. Always. It doesn't matter the roots we give you. The first root is 3, so we fill in 3. The second root is negative 4, so we fill in negative 4, and we work out the basic math accordingly. As you can see in the front, 1, we don't really need to write that down, so we can normally just ignore the 1. Now, x minus a negative 4 is now a positive 4, and we want to make it look just like that. Okay, so x times x is going to be x squared. X times positive 4 is positive 4x. Negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. Drop down your y equals. Yes, we must combine like terms, so that's going to be x squared plus x minus 12. Oops, that does not look like a 12. Let's highlight your final answer. That is a polynomial with a degree of 2. And polynomial, meaning they have more than one term, we have 3 terms total. Now, we do need to find your decimals and graph that out so we can sketch it on that grid. So go ahead and pull up your decimal graph. Let's type in y equals x squared. And we want to do a plus x minus 12. Okay, as you can see here, when you type it in, it's not showing the vertex. So feel free to press. Let me move the screen over really quickly. Press the wrench here on the. Let me extend this out, guys, so you can see it. So you can fix your window of decimals. Okay, so hit this. And I want to make the y a little bit lower. So let's say negative 20. Oh, perfect. There you go. And this bigger a is to make it darker so you can see it, okay? So we are looking for, look at this. So we have the first x-intercept at 3, 0, which is exactly what was given to us. Then we have a negative 4 comma 0. Let's find the y-intercept really quickly, which is 0 comma negative 12. And then if you hit the vertex here, the reason I want you guys to find all of this is that way when we sketch it out, it looks a little bit better if we have all of those details. Okay, now let's go back to your original and then let's sketch it out. Okay, so now we know the equation is correct. Let's go make some tick marks. We want 1, 2, 3, 4, 5. Make sure the tick marks are as best as you can. Okay, evenly spaced out. 1, 2, 3, 4, 5. So we do know that there are two x-intercepts. Negative 3 comma 0. I'm sorry, positive 3 comma 0 and negative 4 comma 0, 2, 3, 4. So those are them. Then based on Desmos, we knew the y-intercept is going to be negative 12. Well, I don't have that many tick marks to make for the y. So I'm going to go down and make each tick mark worth 12 units. Okay, so the y-intercept is 0, 12. Then we knew the vertex using Desmos was negative 0.5 and a little bit below 12. It was like negative 12.25. So now make a parabola. We do know that it is a quadratic based on the degree. And then that's what it should look like, okay? All right, students, example 2 has 1 root, 2 roots, and 3. So 3 roots, meaning that this will have a degree of 3. That is a cubic function, okay? So the standard form is going to be something similar. It doesn't have to be exactly, but it could be y equals ax to the third, ax to the third plus bx squared plus cx, and the constant, let's call it d. Now we are going to assume your leading coefficient is 1. So y equals 1 times, and since we have 3 roots, we will just write x minus and leave the blank spaces to fill in the actual x-intercepts. Okay. Now the first x-intercept is at 7, so x minus 7. Then we have a half, then we have a negative 1. Now in your guidelines earlier, students, we can't have fractions in our equation, so we want to get rid of it by multiplying this right here by 2. If we multiply by 2, we multiply this also by 2 before we FOIL. So let's go, and again, I'm not going to write the 1, so I'm just going to write the x minus 7, and 2 times x is 2x. 1/2 times 2 is now minus 1, and then an x minus a negative 1 is now a positive 1. You can distribute this however you want. You can multiply the first 2 or the last 2 and then the third. So let's just do it in order for this one. X times 2x is 2x squared. X times negative 1 is negative 1x, or just negative x. Negative 7 times 2x is negative 14x. And negative 7 times a negative 1 is a positive 7. Okay. We do need to combine like terms. We have not multiplied out the last root yet, the last factor. So we will do that after we combine like terms. So this will give us 2x squared. In the middle is now minus 15x and drop down to 7. We do need to FOIL this out. So let's FOIL this out correctly. All right, here we go. 2x squared times x is 2x to the third. We are aware that is going to be a cubic. 2x times 1 is going to be positive 2x squared. Negative 15x times x is negative 15x squared. Negative 15x times a positive 1 is going to be negative 15x. I'm just going to write the rest below. Next is going to be 7 times x is going to be 7x. I'm going to drop it right down here because I know those are going to be like terms. And then 7 times 1 is going to be positive 7. So I'm going to drop down the y, guys. Y equals. Okay, let's combine like terms. Are you ready? this is what I'm going to try to add right here. Okay, so 2x to the third, there is no other third power, so that's going to be by itself. These two both have a power of 2, so those can be combined. So 2x squared minus 15x squared is going to be minus 13x squared. Then following that, these two both have a degree of 1, so that's going to be now combinable of a negative 8x. And then the constant of 7 is going to be dropped down. Okay, so now box that up because that is your final answer right there. Okay, so now let's find your decimals. Type it in. Hopefully the 3 roots are correct. So y equals 2x to the third power minus 13, 13x to the second power based on what we just got done doing, minus 8x plus 7. Okay, now again, we can't see everything, so I'm just gonna hit this button over here, the wrench here, and I want more of the positive y's and negative y's. So I'm gonna go down here. Looks like that's not enough, so let's try negative 40. Nope, still not enough. Negative 100. Negative 100, okay. And nope, still not enough. Let's go to negative 150 y's. Okay, that's better. And slightly more than 7, so let's do 10. Okay, so here, let's double check to see if our 3 x-intercepts are correct. We have one x-intercept at negative 1, 0, okay. Positive 1/2 or positive 0.5 here, guys. And then the last root is 7, 0. Now let's double check the vertices here. So we got one maximum here at, that is going to be about negative 0.3-ish and about 8.2. So that's the maximum points on the top. The y value here is 0, 7. And again, you do need to know what these are so we can sketch it out correctly. And another point down here, that's a minimum point. So that's going to be about 4.6, and that's 100, negative 110, okay? So about. So those are the 3 important points in addition to your x-intercepts. So let's go back and sketch it out. Now, as you can see, I'm not going to obviously make my tick marks on the y's 1 unit each because we have a negative 110. So I'm just going to go down, guys, and honestly, I'm going to label this negative 110. Then the x-axis, we can definitely make it by 1. So 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3. And let's on the positive y, we can just, let's say 1, 2, 3, 4, 5, 6, 7, 8. All right, let's plot the dots. Ready? Let's start with the x-intercept. There is 1 at 7, 0. This is the dot. Positive 1/2, 0. This is the second dot. Negative 1, 0. This is the third dot. Then earlier we knew that we had a y-intercept at 0, 7. So 1, 2, 3, 4, 5, 6, 7. That's a y-intercept. And then we had a maximum point at a very small x location. Okay, so negative 0.3 and then like 8.2. So I'm going to put it like this, right there. Then we had a minimum point at 4.6. So 1, 2, 3, 4, 4.5. And then we knew it was like a negative 110 and some change. Now, based on, if you look back at decimals, okay, it starts from the bottom on the left side, it goes up, and then it turns back up to the top. So that's exactly what we want to do. So it starts at the bottom, and then it goes up to the maximum point, and then it loops back just like that. Okay, and then I missed that dot like majorly, didn't I? So let's try that again. Just like that. And then let's connect this side. And you missed that dot just to make it really fat, to make sure I didn't miss that dot again. All right. So again, looks like we have 3 x-intercepts, right? So that means the degree of our polynomial is 3. Now, as you can see here, this x-intercept is at 0. So technically, if we were to write it like this, okay, these are the same. So y equals a is 1. So 1 times, there are 3 x-intercepts. So we will write 3 blank spaces. It's always going to be an x minus, okay? So first x-intercept is 0, fill in 0. Second is negative 2/3, so negative 2 over 3, and the third is 9. Well, x minus 0, students, that's just going to be x, okay? So we don't have to write x minus 0. Now the second one, 2 negatives, will make it a positive, and just like earlier, we cannot have this fraction of 2/3 in there. So we are going to multiply by the denominator. So we multiply that side by 3. We multiply this side by 3. So y equals x times 3x. The denominators we cancel, plus 2 times x minus 9. And we can distribute. So x times 3x is 3x squared. X times a positive 2 is going to be a positive 2x. We were now trying to multiply the last root, okay? So with that, we are going to go, okay, 3x squared times x is 3x to the third. 3x squared times a negative 9 is going to be negative 27x squared. In the middle, 2x times x is going to be a positive 2x squared. 2x times a negative 9 is negative 18x. Drop down the y equals, let's combine like terms. Those are the ones in the middle here. Y equals 3x to the third. And negative 27x squared and a positive 2x squared is negative 25x squared. Drop your minus 18x down. We do not have a constant, and that's okay. For this one, the degree is 3, and we have 3 terms. That is still a polynomial. So now we will type in the polynomial that we just found. So that happens to be y equals, or f of x. You can even go back and go f of x. That's totally okay. Equals 3x to the third minus 27x square. And we have minus 25, my bad, minus 25x square, and then minus 18x. Okay, let's click it really quickly to see. Okay. 3x to the third minus 25x squared minus 18x. Let's double check decimals. Okay, now as you can see here, I can't see the bottom value, the minimum value, and I would like to have more of the positive x value. So I'm going to go in here and put 15 on the positive x, and negative 150 right now on the bottom doesn't seem like it's big enough, so let's make negative 300. Still not big enough. Let's make it negative 500. Why not? Perfect. Okay, so that looks pretty good. Okay, so here we go. We have 3 zeros. The first one is 0, 0. Perfect. The second one is negative 2/3, which is 0.667. And then the last one is 9, 0. So those are perfect. As you can see here, the y-intercept and the x-intercept happen to be the same exact point, which is at 0, 0, aka the origin. It's okay to be the same, okay, especially when it is at the origin. Then we have a maximum point here. Ooh, let me see. So that's about negative 0.3, and the y value is like 3.1. So that's super, super tiny, especially we have like this minimum point on the bottom here. That's about 5.9, so pretty close to 6, and a negative 360. So let's go and plot those. All right, x-axis, I'm just gonna stick with 1 per tick mark, but the y value might be different. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Okay, now the y value let's see, we know the minimum was at a negative 360 and some change. I'm going to go down here and write negative 360. Now, if you don't label your y or you don't label your tick mark, we are just going to assume it is 1 unit. On the y above, I could technically keep it as 1 unit, okay? So we have 3x intercepts, 0, 0. Oh, whoa, that is super fat. Let's undo that dot. All right, so let's, ooh, that was way too fat. There you go. All right, so 0, 0 is one of them. And let me go in and add, I erased that one, so that kind of got deleted. Okay, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 comma 0 is the second. Then negative 2/3, so like right, ooh, that's going to be super close. Right there. So it's not quite a whole negative 1 yet. We try to trace your maximum point, so which is like earlier, negative 0.3 and a little bit over 3. So like super, 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 super close right there. Then you had a minimum point that's really, really low. It was like about 1, 2, 3, 4, 5, 6, almost 6, and about negative 360. Okay, so this is what that should look like. And then cross over this minimum point, trying to make that connection there. Don't miss my connection. Any point that we miss, make it look nice and smooth. Nice and smooth. Okay. Make this dot really big, and that's kind of what it should look like. All right, first let's fix this. I forgot to type in the 0, so that should say 2 minus rad 3 comma 0. So this one looks like we have 4 roots. So 4 roots, student, that's going to be a degree of 4, right? A degree of 4, when we have it in standard form, degree of 4. Now, just to give you an idea of what this would look like, it's going to be ax to the 4th, I know, plus bx to the 3rd, plus cx squared, plus dx. And then, yeah, the constant, obviously, the next letter is going to be e. So we do have, as you can see here, 2 irrational roots. Irrational roots, if you guys remember, it's when we have a number that doesn't really give us a nice perfect root, or a number when you put in your calculator, the decimal goes on forever, but it doesn't repeat. So those are irrational roots. So first things first, we will still start out with the 4 quantities. Okay, 1, 2, 3, and 4. We are still going to have an x minus in each quantity. Then this is when we put in our roots. Now remember, the a value is still 1 if you want to write the 1 in the front, because our irrational root has 2 terms, so we would need a quantity around the roots. Okay, so it's because it's really x minus the entire root, and 2 minus square root of rad 3, or 2 plus radical rad 3 is 1 root themselves. And then the minus 6 will get a minus and a minus, just like that. So it's always a minus when we start out with an x minus. Okay, so let's go, and remember, we are going to multiply the conjugate pair first. If you want to put a 1 right there, that's a good idea. So next we are going to drop down the y equals, I'm going to drop down the x, distribute the minus 1 first, so that's a minus 2 and a minus radical 3. Similarly, drop down the x, distribute the minus 1 first to both of those, so that's a minus 2 and a positive rad 3. Now we can multiply these out, so I'm going to minus 5 here and 2 negatives. We'll now change it to positive, okay? Let's distribute the 2 conjugate pairs. Are you guys ready for that? And be very cautious, okay? X times x is x squared. X times a negative 2 is negative 2x. X times a positive rad 3 is a positive rad 3x. And be careful to not write that x under that radical. In the negative 2 times x is negative 2x. Negative 2 times negative 2 is now a positive 4. Negative 2 times a positive root 3 is a negative 2 root 3. Then next is going to be a negative root 3 times x is a negative root 3x. Negative root 3 times a negative 2 is a positive 2 root 3. A negative root 3 times a positive root 3, students, is really a negative root 9. I'll write that down for now. But some of you guys know square root of 9 is 3. That's just the first two. I'm going to drop down the x minus 5 and an x plus 6. We have not done those yet. And then drop down the y equals. Let's see if we can combine like terms. Are you guys ready? I'm going to drop down the x squared. It looks like that's the only thing there. Let's see what we can find with the, negative 2x, and a negative 2x is the minus 4x. Okay, so those are gone. Let's see what's next. A positive square root of 3x and a negative square root of 3x. Those will be gone. What else am I missing? Okay. A negative 2 root 3 and a positive 2 root 3. They are gone. Drop down the 4. And guys, negative root 9 is going to be negative 3. And that's that. Let's drop down the x minus 5 times x plus 6. We have not foiled those. Okay, let's combine like terms some more. So this is x squared minus 4x, and then 4 minus 3, that's a positive 1. Drop down those two guys in the back. Okay, do you want to hear one good news so far? When you guys have a degree of 4, students, or higher, okay, as long as you guys get rid of all of the complex roots, aka the i's, and all the radicals and all the fractions, you can leave your answer like this. What that means is you don't have to FOIL it out anymore. Oh my gosh, yes. Okay, so there are 4 roots, and there are 4 real roots. 2 of them are ugly complex numbers, but that means they should still intersect the x-axis. All right, so let's type in the polynomial function that we just got done FOILing out. Remember, we just said if you have a degree of 4 or higher, you do not have to FOIL the rest of these out. You can stop when all of your numbers are non-fractions. This is a 6. And non-imaginary, non-radical. Okay, so students, as you can see here, let me just change my x's to be a little bit smaller than negative 30. Okay, so x's, why don't we go to maybe negative 10? Yeah, negative 10 to positive 10. Okay, now the y values are in the 5,000. Probably don't need that. Okay, how about we go negative 100 on the y and then positive 100 on the top. Oof. All right, so the negative 100 is not really covering the bottom. Okay, so I went from a negative 1,000 on the y-axis to positive 100 on the y. And all right, and I'm just gonna move it down a little bit so you can see it looks like a W. So we have one x-intercept at negative 6. We know we're supposed to have 4. Okay, 2 of them will be a decimal, ugly decimal. A second one is going to be the 0.268, so like 0.3. So we know we had one at a negative 6. The second one is going to be about 0.3. Then the third one right here, it's 3.7. And we know the last one is going to be a nice one right there at 5. Yes, we know all of that. Now, let's look at the y-intercept really quickly. The y-intercept is 0, negative 30. Then we have this minimum point, guys, in the bottom. So that minimum point is about negative 3.9, almost 600, huh? Negative 594. And then we have a maximum point here. that's, let's see what that is. About 1.7 and 74. And one more low point here. This is called minimum point 2. Oh, come on. That's about, let's see, 4.4 and then negative 17. So we want to plot all the x-axis out, plot the y-intercept, and then the minimum point in the bottom, a maximum point in the top, and then another minimum point, and sketch that out for example number 4. And we should be done with example number 4. Okay, the tick marks looks like I'm just going to need about like 6 total on the left, okay? So 1, 2, 3, 4, 5, 6. And we do know we have 1 at negative 6. And we just need 1, 2, 3, 4, 5. We have 1 at 5. And we do have a tiny one at a positive 0.3, somewhere there. We have another tiny one at 3.7. Those two decimal ones they came from the two irrationals. So 1, 2, 3, 3.7 is right there. Remember we talked about the y-intercept being at negative 30, and then we have a minimum point almost like 600. So I'm just gonna make this right here negative 600. Okay, so now I'm gonna get my pen back. Okay, so the first minimum point was negative 1, 2, 3, 3.9, and looks like 594. So let's make that dot there. And then we have the y-intercept is 0, negative 30. We have a maximum point at like 1.7 and then like 74. So let's say this is 17 and let's say 74, okay? Okay, so we have negative 1.7, so somewhere here, up in 74, and then we have a minimum point 4.4, so 1, 2, 3, 4.4, and then, oh, that shouldn't be at 0. Oh, come on. 1, 2, 3, 4, 5. So 4.4 down to like negative 17. So let's make it right there. All right. We remember what it looked like. It looks like a W. Sorry, I have to go all the way through. Looks like a V. Up, 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 up. Down, 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 down. And then I forgot a dot at 5 because I accidentally erased it earlier. Loop back up. Okay, let's see if that's somewhat similar to what we should have. Okay, not perfect, but pretty close. Okay. Wow, look at this one. This one's giving us 2 complex roots. And remember, guys, complex roots will always come in conjugate pairs, okay? So because it's 2 roots, the degree is going to be 2. So we are going to have a quadratic. So when it's all said and done, our standard form should look like ax squared plus bx plus c. But because we have complex root doesn't mean, guys, it's any different. Our a value is still 1. So by now, we don't really have to write the 1, okay? So we can just write 2 quantities. Actually, let me make it a bigger quantity because I need more space. So we are still going to start with the x minus and an x minus. No difference here at all, except because we do have 2 terms in the roots themselves. So we are going to write a quantity, and it's a 5 plus 2i. Over here, and it's going to be a quantity of 5 minus 2i's, 2i's, and like that. And we're just going to FOIL it normally. So to FOIL it, this is really a 1 right here. So to distribute that first, and then we distribute the second. And so again, this is going to be a multiplication of a 3 by 3 when it's all said and done. So negative 1 times 5 is going to be negative 5. Negative 1 times a positive 2i is now a minus 2i. Same thing with this. Put a 1 here when you don't see any number and distribute. So x minus 5 and then x, and then, I'm sorry, and then negative 1 times 5 is -5, and -1 times a -2i is now a positive 2i, so positive 2i. Okay, so it's just going to be a 3 multiplication with 3. You just have to do it very cautiously and slowly. Ready? X times x is going to be x squared. X times a -5 is minus 5x. X times a positive 2i is a positive 2xi. No difference at all. Next, -5 times x is going to be a -5x. I already have it down here, so I'm going to line it up like this. Some of you can just keep going like this. It's up to you. It's a personal choice. But if I line it up or you write it horizontally, then you can just, you know that you will have to combine like terms. That's the final verdict, okay? -5 times a -5 is now a positive 25. -5 times a positive 2i is a negative 10i. Next, ready? Negative 2i times x is going to be negative 2xi, or 2ix, okay? Negative 2i times a -5 is a positive 10i. And negative 2i times a positive 2i is negative 4i squared. And again, that I squared is -1, so we will have to change it. We have to combine like terms, so let me drop down the y equals. There's currently only one x squared, so that will stay. So one x squared stays, okay? -5x and another -5x, that is now a -10x. Then positive 2xi and a -2xi, that will be gone. Then we have a -10i and a positive 10i, that will also be gone. We only have one positive 25, so that stays. But this one right here, students, I squared is a -1. So -4 times a -1. We do have to make sure we simplify all the way through. Okay, so we are going to have a positive 4 due to a -4 times a -1. Well, no, we cannot leave it like that. We always have to simplify until the very end. So our quadratic equation is x squared minus 10x plus 29. That is what we are going to box up, and pull up your decimals to graph that out. All right, so let's type in the polynomial that we just got done foiling. So x squared minus 10x plus 29. Now, as you can see here, I'm gonna move this down, that's because I can't see much. So I'm going to get rid of this, a lot of the negative. I'm gonna do -10, okay. So this is what I needed. Well, we know, since we have complex roots, students, it's not going to intersect your x-axis, and your x-axis, it's right, whoa, what is that, right here. Okay, this is your x-axis right here, and your y-axis is right here. Okay, complex and imaginary roots will not cross over or touch the x-axis, which obviously makes a lot of sense. Only real roots will do that. So let's move it up a little bit more to see what's going on. I'm going to X out my exit drawing and move up. So we just need the vertex in the bottom to sketch out our graph. That's going to be 5, 4, and the y-intercept is 0, 29. Let's go back and sketch that out. Okay, I'm going to go in, guys, and just kind of label the y tick marks. How about, should we do 29? So 10, 20, 30, just like that. And x-axis, 1, 2, 3, 4, 5. And we knew the vertex was at, this is -10, okay? The vertex was at 5, 4, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 4 is like right about there. And then the y-intercept was 0, 29, so we know it's right under 30. And then we know it's a degree of 2 because it is a quadratic, and they only gave us 2 roots to begin with, so it should make a U shape, and those are the 2 dots. Last example of the unit, and it looks like it's the hardest example. Oh no. Okay, oh, looks, I'm missing a 0 here, so this should have been a comma 0, like that. Okay. All right, guys, so 3 roots start out with 3 set of parentheses right away. We do know 3 roots mean it is going to be a cubic function. So the degree of this should be 3, right? So when it's all said and done, you should have ax to the third plus bx squared plus cx and then plus d. It doesn't have to be exactly like that, but at least a 3 power has to be there. As you know earlier, we are going to assume the leading coefficient is 1. So yes, you can write it in, but you don't really have to. We will start with all x minus. Okay, the first root is going to be 3, so we put in 3. Because it is a quantity, that meaning that you have more than 2 terms, so we're going to go do another parentheses inside. So x minus the whole complex root is 7 plus 8i. And then over here, 7 minus 8i. So don't forget. Now, students, you can go in and put a 1 in front of the parentheses so you can correctly distribute the inner parentheses, because we have a lot of parentheses here. So first things first, I'm going to drop down x minus 3. Distribute this inner parentheses here, so do it very slowly. So drop x down. Negative 1 times 7 is minus 7. Negative 1 times 8i is negative 8i. Similarly to this over here, drop x down. Negative 1 times 7 is going to be minus 7. Negative 1 times a negative 8i is positive 8i. Now, always, 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 students, multiply the conjugate roots first. So that means these two, you want to multiply those first. Okay, so let's do x times x is going to be x squared. X times negative 7 is going to be negative 7x. X times a positive 8i is going to be positive 8xi. In the middle, we're going to take negative 7x. Negative 7 times x is negative 7x. Negative 7 times a negative 7 is positive 49. Negative 7 times a positive 8i is negative 56i. Then we have, let's see what's the next color. Last one, 8i, negative 8i times x is going to be negative 8xi. Negative 8i times a negative 7 is positive 56i. Negative 8i times a positive 8i is a negative 64i squared. Whoa. Now, some of you remember from the last unit that I squared is negative 1. So yes, you can go straight up by writing positive 64. Now I'm going to put big nasty quantity there, drop down this quantity, and drop my y equals down. Okay, we still have to FOIL the ugly, I'm sorry, not FOIL, simplify this whole thing right here, but I don't want to forget these, so I'm going to copy this over. Okay, let's look at what we need to simplify next. The x squared is all by itself, so we are going to drop that down. Let's see if we have another. So 7x, negative 7x is another negative 7x right there. So it's now negative 14x. Okay. We have 8xi, so 8xi and a negative 8xi. Those will eliminate each other. We have 49 right here. That's the only thing that's here. So I'm just going to copy that down. Okay. Next, looks like we have a negative 56i and a positive 56i. Those are going to be gone. And the only thing that I have not dropped down is the negative 64i squared. But I square, students, is a -1. So we do need to distribute some more. All right, so let's simplify some more. So I'm going to drop down the x minus quantity because right now there's nothing we can do. We need to drop down the x squared. We need to drop down the minus 14x. But these two right here can be simplified a bit more. Drop down the 49. -64 times a -1 is now a positive 64. And we're going to combine the last two terms. Drop these down. And no, we are not done. We need to FOIL a little bit more after this. So x squared minus 14x. As you can see, 49 plus 64, that's going to be 113. Okay, and then we have to FOIL some more. Okay, so x times x squared is x to the third. We are expecting a degree of 3. X times -14x, students, is -14x squared. X times a positive 113 is positive 113x. -3 times x squared is -3x squared. -3 times a -14 is positive 42x. -3 times a positive 113 is a -339. Drop down the y equals. Let's see what else we can combine. So x to the third, there's not another x to the third, but there are two x squared terms. That would be a -17x squared. Those are gone. And we have a -113 and, a positive 113 and a positive 42. So that's a bigger positive of 155x. And then we drop down the constant of a -339. Okay, let's highlight the final answer. This is the cubic function that we are expecting. Okay, so as you can see, if you remember that we only have one real root, okay? One real root, meaning that we should only have one location that this cubic function intersect or touch the x-axis. The two complex, 7 plus 8i and 7 minus 8i, will not show up on the x-axis, and that means when we do Desmos. So I already entered that in. As you can see here, it looks like it's a straight line, and that makes sense because remember, we only have one real root. So let me just make the x values a lot smaller. Let's go from -5 to like +5, okay? And we do know the y-intercept. If we look at our equation, y-intercept is going to be when x equals to 0. So the only thing that's going to matter is a -339. And if we look at Desmos, it does have a y-intercept at 0, -339. Okay, so if we, let's just say that I want to change the y-axis a little bit higher. So let's say y, positive y, we can make it like 100. And how about, actually just make it positive 600. Okay, so can you guys see this? So as you can see, it's not, where did that go? It's not a line. So oftentimes students feel like, oh, you know what? I don't see everything, so it's going to be a line. That's not true. So make sure we check it out and say, hey, look, it's not a line at all, right? It's going to go up just like that. So let me pinch it in a bit more, and it looks just like that. Beautiful, isn't it? Okay, let's go back and sketch. One x-intercept at 3. So 1, 2, 3, 4. We can definitely make that there. And we have a y-intercept at 339. So we can make a dot here. We do know it's not a line, so it's going to go just like that. And that's the end.